Then, dako na tayo sa. So, I hope na trinay yung panoorin yung sinend kong videos. Para hindi na natin hindi ko na masyadong explain kung ano yung gagawin natin. Let's start with sample 1. Lapit na mapuno. So, let's try example 1. Cracking moment. Assuming that the concrete is uncracked, compute the bending stress in the extreme fibers of the beam shown for bending moment of... Nakikita ba pala yung ano ko? Sorry, saglit. Kaya ito na-share. Yan, nakikita na yung screen ko.
Yes, sir.
Double check ko lang kung naka-screen record. Okay, live. Okay, so balikan kong basahin. So, let's try example 1. Cracking moment. Assuming that the concrete is uncracked, compute the bending stress in the extreme fibers of the beam shown for a bending moment of 560 kilonewton meter and the normal weight of concrete. A normal weight concrete has a F prime C 25 equivalent to 25 MPa and a modulus rupture of 0.62 square root of F prime C. So, okay. So, first step dito para for us to compute the cracking moment. So, yun ang hinahanap natin Ay, sorry. Hindi, bending stresses pala. Hanap natin. Tama ba? Bending stress. Okay, okay. So, first step is to determine the moment of inertia of the section. So, itong kabuuan na to, hahanapin natin yung moment of inertia niya. So, we assume the section is just simply a rectangular section. So, we did not consider the actions or the effects of the rebars, itong bilog-bilog na ito. We call it rebar. Okay, so we did not, our assumptions here na yun nga, rectangular muna siya at hindi pa gumagalaw o hindi pa tumutulong in terms of bending itong mga rebar natin. Okay, so first step is to determine the moment of inertia. So dito, solve IG or the gross moment of inertia natin. So simply, kung balikan nyo yung strength of materials nyo, this formula will appear. Okay? So, mukhang nagkamali ako sa may typo ako dito. Di dapat ito. Let's check kung same lang yung output na lumabas. Dapat square yun. So, same lang. Okay. So, just simply multiplication. 500 raised. Tandaan nyo, yung 500 is always the total depth nung ano natin Total depth nung ating section. Yan, depth. Then, yung B is the width naman. Total width na. From here to here. From the section itself, makikita naman na yung total depth is 500 and then the total width is 400. So, yun yung na-input dito. So, 500 cubed times 400 divided by 12, then we will have an answer of 4.167 times 10 raised to 9 millimeter to the fourth. Okay. Now, to compute for the stresses, we will just simply use the flexural formula. So, kung Hindi nyo pa ano to, we call it the flexural formula. Which is just simply m times y is equal to the flexural stress is equal to m, the moment, times dy. Mamaya, saan yung y, ano bang ibig sabihin ng y na yun? Divided by the moment of inertia natin. So, in this case, madali lang siya dahil yung, burahin ko na nga to, na taon na yung neutral axis niya is just acting, is just, ulitin ko, yung neutral axis natin is just simply at the centroid of the section or nasa gitna lang nung ating section. So, it's just simply 500 divided by 2. So, yun yung, that will act as our, what we call the neutral axis. Or, for simplicity's sake, we call it the NA. Okay? So, kaya tinawag na neutral axis yan, na taon, na dyan sa linya na yan, the section does not, di siya nakakaranas ng stress dyan sa portion na yan. Okay? Ngayon, yun nga, after determining the location of the neutral axis, you can now determine y. Y is just simply the distance from the neutral axis to a specific point. So, for example, we want to determine the stress at this section, then the distance from the neutral axis, yan yung y natin. Okay? Yung distance from the neutral axis up to the point that dun sa kailangan natin malaman yung bending stress, yun yung y natin. But for this case, we are hinahanap lang natin yung parang maximum stress niya. So, then logically, syempre, ano bang magbibigay sa atin ng pinakamataas na stress dito? Of course, the outermost part of the section. Pinakamalayo niya. Which means dito sa portion na to, sa pinaka-top niya. Sorry. Nag-i-straight yung arrow. Okay, so at that point, so dito sa, let me just specify it. So, dito sa portion na ito, yan yung pinaka-outermost natin. So tandaan niyo, for us to determine the maximum stress of a section, always at the outermost part of it. Extreme fibers ang ibang term para doon. Okay? Usually, pinapangalanan yan as C. Extreme fibers. Okay. Nataon dito na both sides have an equal extreme distance of extreme location of the extreme fibers. Okay? So nataon dito na ang ibig sabihin nito numerically yung stress na makukuha natin dito sa portion na ito okay, sige. Yung stress na makukuha natin dito sa portion na ito, gagawin ko na ng pula, is also the same stress dito sa baba. Okay? Ulitin ko, nagkataon kasi na equal lang sila. Tandaan nyo, yung location, yung distance na to is dictated kung nasaan yung neutral axis natin. Okay? E nataon nga na dahil rectangular lang ito, nasa gitna lang. For the next example mamaya, makikita nyo na ang neutral axis will not always be at the, hindi ganun kadaling hanapin. Okay? Nataon lang dito sa example na to na medyo mabilis hanapin at gitna lang. Okay? Okay. So, yun nga. Y is just simply equal to 250 mm. So, it's just simply multiplication and division. So, input nyo ito yung moment natin. Yung highlight ko, ito yung moment natin. Minultiply natin siya ng, ino-convert natin yung, itong ano niya, yung m niya, itong meter into millimeter. Okay? So, sa 1,000 millimeter, meron tayo isang metro. So, cancel yung dalawang yaan. So, matitira is millimeter. Then, at the same time, minultiply din natin yung kilonewton up into, kinonvert natin yung kilonewton into newton naman. So, sa 1,000 newton, meron tayong 1 kilonewton. So, makakancel din ito at saka ito. Then, ang matitira na lang sa ating product na yan is simply, just simply newton millimeter. Okay? Then, multiply it by 250, our y, ito yung y natin. Yan yung y. Then, divided by the moment of inertia natin dito. Okay? Giving us an answer of 2.99 Newton per mm squared. Likewise, ito is equivalent to megapascal. Tandaan nyo, let me have a note. Now, kung meron kang 1 Newton per mm squared, equal lang yan sa, bumaba siya na, equal lang yan sa 1 MPa. So, tandaan nyo na yan. Ang daling i-memorize lang yan. Okay. So, ito ang ginawa ko na lang, ni-round up ko na lang siya. Okay? So, ito yung magiging maximum stress natin sa sa section na ito. Then, next step, yun lang kung tutusin, ang hinahanap lang naman is the bending stress. So, therefore, ito na dapat yung sagot natin. But, dahil reinforced concrete yung pinag-uusapan natin, we have to determine if the section has already been cracked. Okay. So, hindi yata maganda yung blue. Color na lang. So, ito na yung answer natin. So, an additional question na nilagay ko dito is, hindi ko determine if section has cracked. Hindi ko na ilagay. So, but I will update. Okay. So, now, for the next step is to solve for the modulus of rupture. So, sa madali lang, gagamitin lang yung formula na binigay, which is FR is equal to 0.02 times square root of F prime C. So, therefore, lumalabas na 3.1 MPa yung modulus of fracture. Now, ano bang ibig sabihin ng 3.1 MPa na yan? Okay. So, sinasabi ng formula na to, itong formula na to, na pag naabot ng stress sa beam ito ng 3.1, ibig sabihin, magi-start na magka-crack yung section natin. So therefore, itong number na ito, itong numero na nakikita ninyo dito na 3.1, should be compared doon sa na-compute nating stress dito. Okay, kung kayo ang tatanungin ko, sa tingin nyo ba umabot yung stresses nung beam natin? Sa tingin niyo, anyone? Umabot ba? Nag-crack kaya yung section natin? Of course, meron na akong remarks dyan, but from the answer, halatang halata na hindi pa nag-crack yung section natin. Kasi, bakit? Yung section natin, yung stress natin, is much lesser than doon sa rupture o modulus of rupture. So therefore, the section is assumed not to have cracked. Okay, so ito yung parang comparison natin. The stress na na-compute natin is less than doon sa modulus of rupture natin. So, ayun nga, yun yung magiging concluding remarks ninyo na kinompare ninyo, so hindi pa pala nag-crack tong section na ito. So, let's continue doon sa ano. So, ngayon, anong, in terms naman sa uh, real life situation, what does this imply doon sa itong computation na ito? Of course, visually doon sa beam, itong section na to, beam ang tinutukoy natin ha. So, visually, syempre, wala kang crack na makikita doon sa section mo. So, malinis tignan yung beam ninyo, di ba? Ngayon, sabihin natin ang na-compute natin dito is 3.2. Sabihin lang natin hindi ko na ano yun to, basta sabihin lang natin na yung computation natin sa baka nangyari tinaasan itong moment na ito 3.2. So therefore, nag-exceed na siya doon sa modulus of rupture. Therefore, the section will now have visible cracks. Assume to be have visible cracks. Laging may assume dahil tandaan niyo itong formula na to is just simply an empirical method. Ibig sabihin ng empirical method, kasi ang pagka-crack talaga sa beam is probabilistic. Ang ibig sabihin ninyo, hindi siya basta-bastang nako-compute lang, kundi nadadaan yan sa probability. Okay? Kaya laging ang sagot is laging may assume. But, of course, mas safe ka na i-assume na nag-crack na yung section mo. Okay? So, balik ko lang ito. Okay, so yung section, my final remarks is the section is assumed not to have cracked. Okay? So, next tayo. So, dito medyo bago tayo mag-proceed sa next na example, any question? Any reaction or baka nagkamali tayo sa computation, pwede nyo i-point out. Seems like wala naman. Sana nakikinig. Okay. Okay, let's proceed to the next sample. So, cracking moment pa rin tayo. So, the T-beam shown, ito yung section natin. So, there are two questions answered here. So, calculate the stress in the concrete at the top and bottom extreme fibers. Esto. Under a positive bending moment, 100 kilonewton meter. If F prime C is equal to 21 MPa and normal weight concrete is used, what is the maximum uniformly distributed load that the beam can carry if it is used as a simple beam with a 8-meter span? Okay. Merong positive bending sana sige, pero remember that pag nag-beam ang isang section, nag-deflect ang isang section, pag pag ganito ang shape niya, we call it positive bending. Okay? Or in some plus. Okay. So remember that this is a positive bending. But if the beam deflects the opposite direction, we have a negative bending. Ngayon, sir, ano bang implication pagdating sa section yan? So, may pinagkaiba yan, may pinagkaiba ba yan, sir? Oo, meron yan. Remember that in a positive bending, palitan ko lang ng kulay, yung top yung top section, yung extreme top nung section natin will receive a compressive stress. Okay? Compressive stress. And the bottom part of the section will experience a tensile stress. Okay? So magkaiba 'yan. Vice versa, dito sa negative bending, itong bottom part naman will experience compressive stress at yung top part naman ng section natin will experience tensile stress. So magkaiba 'yan. Okay? So in our computation dito, uh, itong na bandang taas kasi positive bending yung ano niya. So yung bandang taas will experience compressive stress, then itong nasa baba naman will experience tensile stress. Okay. So yan yung magiging ano natin pinagkaibahan dun sa unang computation natin. And likewise, dun sa neutral axis, hanapin natin yung location niya at this ano. Okay. So, let's compute. First is to locate the centroid or sakto kasing nandyan yung ating neutral axis. It coincide with this centroid. Naglinya sila. Ang ino. Okay, okay. Okay. So, in this computation, you can have a lot, pwede ka magkaroon ng maraming solution dito. But this solution is what I suggest. Kasi tandaan nyo din na napansin nyo kasi na yung section is nahati sa dalawang components. We have this component and we have this component. Let me change it to red. Okay. Now, in some cases, for example, gusto mong i-prove na tama ba yung ginawa ni sir, tama ba yung sabi ng libro, pwede mong gawin ganito. You can have three components. So, pwede mong hatiin sa ganyan. Oops. Then, pwede mong gawin ganito. Okay? Pwede rin yan. And I will tell you, it will just yield the same answer. Okay? Pero kung medyo masokista ka, pwede mong gawin ito. Biruin mo, you will have three components. So, yung area mo, instead na dalawa lang, yung compute mo, meron ka ng tatlo. Okay, so, in my solution, I prefer this two-component part. So, let's say that the first component is A1. The second component is A2. Then, their respective distances is displayed in this figure. So, I just assume a location of the neutral axis from the distance from the bottom as y bar. So, hindi pa natin alam kung ano yung distance ng neutral axis from the bottom. Ang reference ko na ginawa is yung bottom. Okay. So, baka itry nyo. Let's try. Sir, baka pwede namang 700 plus 130 then divided by 2 lang. So, you can try it. So, let's have a trial. Lagay natin. Trial y bar. Lagay ko yung y bar natin. Accent y bar. So, let's ilagay natin yung value. So, 700 plus 130 divided by 2 is just simply 150. 415 mm. Okay. So trial to pwede nating ilagay joke. Joke lang ito. Na taon na ano no, na parehas no. Pangkatawa-tawa. Okay. Okay. So, yun nga. Proceed na tayo. First is to locate the centroid or the neutral axis. Of course, for the area 1 or A1, it's just simply, dahil rectangle lang siya, it's just simply the multiplication of the side, 1525 mm, times the depth of 130. Then for the A2, itong part na ito, we have just simply 700 times 300. So, we have this answer. So, double check ko lang. Baka nagkamali ako ng type. Ayun na din. Ulitin ko na ang pag-input sa calcu is skill. Hindi yan basta-bastang na-acquire ng isang gabi. Kaya baka pagdating ng board exam, ang bagal nyo mag-type ng numero sa calcu, kasalanan nyo yun. Hindi kasalanan ng kung sino man kasi hindi kayo nag-practice mag-solve sa calcu ninyo. Okay? So, as much as possible, pag nagdi-discuss tayo or any sa mga professor ninyo, ilabas yung calcu nyo, then try to input whatever it is presented. Okay? Kasi ulitin ko, skill yan. Skill. I always use this analogy, but of course, kung gusto mo maging basketballista, hindi ka gagaling hanggat hindi mo sinusubukan mag-dribble or mag-shoot ng point. Diba? Alangan iisipin mo lang, gusto ko maging basketballista, gusto ko maging basketballista. Isipin mo, and then one day, basketballista ka. Hindi ganun ang nangyayari, di ba? So, you have to practice. Ganun din sa mathematics, ganun din sa engineering. You have to practice. Okay? So, then the addition. So, area total yung kabuuan. Yan ako na. Dala muna. So, we have area 1 plus area 2. Meron tayo nito. Then, copy lang natin ito. Then, baka nagkamali ako. So, let's try to input. So, we have 408,250 mm squared dahil area lang pinag-usapan. Okay. So, now, we can now determine the centroid. So, to locate the centroid, we will use the Varignon's theorem. I hope na ito na-introduce sa strength of materials niyo. Varignon's theorem. Okay. So, it's just simply the moment area of the total area times its from the neutral axis at any reference point yan kasi pwede tayo mag-reference dito tayo sa taas. Pero yun nga, nataon na dito tayo sa baba. So, it's just simply the summation of the components. So, area 1 times yung A1 niya plus yung A2 times A2 niya. So, sinasabi lang nitong theorem na ito is just simply equal dito sa components niya. So, input the area total times ito yung unknown natin. Then, input, ito magiging ano to. So, A1, Y1 plus A2, Y2. So, kasi tandaan ninyo, yun yung assignment natin per component. So, sa component 1, we have Y1. Sa component 2, we have Y2. So, nataon naman na 2 components lang yung ano. So, remember yung ginawa ko na hinati ko sa 3, ganun yung gagawin nyo din dito. So, instead na 2 components lang, magkakaroon ka ng panibagong component dito. Okay? Which is, in terms naman sa pag-i-input sa calcu, masyadong mahaba yung pag-i-input mo sa calcu. Okay? So, then, gawin nyo dito, kunin nyo tong sum na to. So, we have 19,8250 times 765. O nga pala, before we proceed that, paano nakuha yung mga 765 saka itong 350? Okay. So, Y1 is determined by kukunin natin yung 700. Tandaan nyo yung y1 na yan must be located from the reference point na ginawa natin up to the centroid of that section. Okay? Centroid, dapat gitna. Ayan. So, with that knowledge in mind, for you to determine, so, ano ka na lang dito, for you to determine y1, y1 is equal to 700. From dito sa bottom na to, aakit tayo ng 700. Then, yung kalahati ng 130 plus 130 divided by 2. So, we have, try ko na lang din input sa calcu. So, meron tayong 765 mm. Okay. Likewise with y2, mas madali ito dahil tandaan nyo din yung y2 is determined by locating the centroid of this component. So, ano ba tong centroid nito? Meron tayong rectangle. So, it's just simply kalahati ng ating height. So, meron tayong height na 700 divided by 2. So, therefore, meron tayong 350 mm. Okay? So, ganyan na-determine yung y1 sa y2. Okay? So, now, let's proceed. So, area 1 times y1, then plus area 2 times y2. So, compute natin. 198,250 times 765 plus 210000 times 350. So, we have, okay. So, siguro magandang gawin muna is kunin lang natin ito. We have 225,161,250. Okay. Now, copy ko lang ito. Equal to, syempre, ito yung equivalent niya. Now, divide both side with, i-divide nyo both side ito with this number para ang may iwan sa kabila is yung y bar na lang natin. So, dividing it with 408,250. So, we have y bar is equal to 551.453. So, from this point, ulitin ko, from this, palitan ko yung kulay niya, from this red line, yung location ng neutral axis natin is 551.52. Okay? So, yan yung location natin from this red line, from this bottom line natin. Okay? Yan yung reference natin. Okay? So, therefore, yung trial na ginawa ninyo, so hindi uubra yung total depth, yung kabuuan na depth, divided by 2. So, hindi uubra yan. Okay? So, talagang joke lang ito. Yun na lang, hindi nagparehas dun sa sagot. So, therefore, ito yung sagot natin. So, ni-round up ko pala. So, 551.53. Okay? So, this quickly means that yung y bottom natin, so may pasok pa rin. So, this simply means that yung y bottom natin, yung y bottom is the same as y bar. Then, yung y to the top natin is now just simply the total depth. So, 700 plus 130, ililess nyo yung bottom. So, therefore, ito yung distance naman ng YT natin. Okay? So, okay. So, bago tayo mag-proceed, sino may tanong muna? Meron ba? Meron ba? Okay. Sana nakikinig nga naman talaga. Okay. So, now, siyempre, hindi pa dun sa formula natin, di ba, tandaan nyo, the stress, flexural stress is equal to my times I. So, ito, given itong m, but the y, yan, na-compute na natin yung y, wala nang problema dyan. Then, the next problem is determining the moment of inertia. Okay? So, yun yung susunod na step natin is to determine the moment of inertia. Okay. Yun nga. Let's compare. Medyo burahin ko na ito. At naka-record naman tayo. Medyo hang yung while waiting, any question? Any tanong ba? 46 kayo ngayon. Ang tong ay itong word. Wala kasi, peke kasi yung na-install ko eh. Wait. Pero pwede ko na lang i-force na lang din. Open ko na lang. Okay. Close na. Okay. Balik ko lang. Ako, yun lang. Nagano ulit. Saglit ha. Ayusin ko lang. Okay. So, nakikita ko ulit yung screen ko? Anyone? Nakikita
Yes,
na
sir.
ulit? Okay. So, I hope na hindi na maulit. Okay. So, full na sa. So, determine the moment of inertia about the neutral axis using the transfer formula. Okay, I hope, ulitin ko, laging talagang I hope ito na na-discuss sa strength of materials. So, hindi ko pati. Ayan. So, ito lang simply is the transfer formula that I've been pertaining to. Okay? It's just simply para malaman natin yung moment of inertia. Lahat ng moment of inertia with respect to the neutral axis. So, it's just simply equal to the moment of inertia of each component plus the area of the component times the distance of the centroid to the neutral axis squared. Okay. So, in this case, we have two components dun sa ginawa natin. Then, we have the moment of inertia 1, moment of inertia 2, plus the area of the component 1, then the distance of the component 1 from the neutral axis to its neutral, to its, anong tawag ko na dito? Sa centroid niya. Okay? Ganon din sa component 2, squared. So, therefore, then we will only use the formula I is equal to base times d raised to 3 divided by 2. Okay, so yan lang yung gagamitin natin. So, from this, so component 1, meron tayong 1525 plus, times the depth 130 cube divided by 12, the same as the component 2. And then, kunin yung area nila, then the distances, Okay. So, the same with the distances, almost, dahil ang nangyari dito kasi baka ang gawin nyo naman, kopyahin nyo lang ito. Yung Y1 gawin yung D1, yung Y2 gawin yung D2. Hindi ganun yon. Remember that our reference line is at the bottom. So therefore, yung distance niyan reference to the bottom. Okay. But in this case, ang reference natin ngayon is the neutral axis. So, D1 is computed as, tandaan nyo, yung D1, paano ba natin didiskartehin ito? So, ano ba mga alam natin na sukat? So, tandaan ninyo, meron tayong sukat na from this point, dito sa point na ito, up to the neutral axis, we know that it is equivalent to y bar, itong distance na ito. Okay? So, ulitin ko from this distance, from this point, alam natin na yung distance na yan is ry bar. So, alam natin na yung distance na yan is y bar. So, ngayon, tandaan nyo, yung distance na D1 dapat naka-reference siya sa neutral axis up to the centroid of the component. So ibig sabihin, we can say that pwede natin gawin, tandaan nyo din na yung distance na ito from the neutral axis up to the top part of the beam, di ba yan naman yung YT natin? Balikan natin yan yung YT natin. Itong distance na to up to this part is YT. So why not ang gawin natin, YT, ililess natin yung kalahati ng 130. Kasi tandaan nyo, 130 ito, then dahil rectangular siya, yung centroid niya is just simply the half of the depth, di ba? So, therefore, YT, so copy natin ito, YT, minus, ilan yung kalahati ng 130? So, we have 60. So, therefore, we have 278.47 less 6. We have 213. So, yun yung nakuha natin. Ito. So, ganun din, didiskartehin nyo din yung D1. So, paano yung D1 naman? So, alam natin na ito is the bottom. So, medyo mas komplikado kasi hindi mo pwedeng kalahati nung naman sa okay. Paano natin didiskartehin yung D2 naman? Actually, pwede pala natin gawin yun. So, itong Y bar or YB natin, tandaan nyo itong YB to this point. Pwede nyo lang ikunin yung half nito, di ba? So, yung matitira na lang, so from this point up to this point, alam natin na yung distance na yan, kalahati nitong distance ng component 2 natin. So therefore, kunin natin yung YB less the half of the total height of this component, which is, yan 700. So 700 divided by 2. So therefore, ano ba yung YB ulit? YB is this less 350. Therefore, 551.53 less 350. We have 201.50. So therefore, nasolve natin yung mga D1. So just simply input it to the formula. Then, lumalabas na yung ating moment of inertia with respect to the neutral axis is equal to 2.64. So, i-type nyo na din Type ko na lang just to make sure na tama yung mga pinagta-type ko dyan. Ang yata to type ko. Yan. Ano naman yung... Okay. So, anyone na... Dali, kakamali yata ako ng type. Anyone na nag-try? Ano?
Iba din, sir.
Ano?
Iba din po
Iba.
lumabas.
Sige. Ah, okay. So, ang tamang sagot is 1 point. Tama ba? Kayo din? 1.90.
Yes,
Kada
sir.
mo.
Yes, sir.
So, don't worry naman. There are ways to double check naman ito. So, siguro, pero next meeting ko na i-discuss kung how to check dito. So, let's remove this. Let's assume na ito na yung tama, then replace this. Okay. So, i-update ko na lang yung ano. Don't worry, we have ways to double check this answer, okay? Siguro, gamitin natin AutoCAD next meeting to double check this answer. Okay, so, now, nakuha na natin 1.94 times 10 raised to 10. So, we can now determine so mali na rin ito. Palitan natin ito, palitan. Shoot nyo. Tama is 1.4344. And for the bottom naman, we have 2 point. Okay. So, tama ba? Pati kayo, ito yung nakuha ninyo, 1.44 saka 2.84. Okay. So, siguro dito muna tayo mag-end. Ito. Now, if we are going to compare the modulus of rupture, sakto ba? 0.62 times square root of 21. We have, sakto. 2.84. So, okay. So, we have an answer of 2.84 sa modulus of rupture. So, okay. So, if we have to compare, siyempre ito yung sinasabi na niya. Ito yung stress sa top, ito yung stress sa bottom. But remember that ang modulus of rupture, ang modulus of rupture is just simply the maximum tension stress of concrete. Okay. In other terms niya yan, it's just simply the maximum is tension stress of concrete, ang modulus of fracture. So, sa tingin nyo ba, i-consider natin yung stress sa top? Remember, dahil may positive bending tayo, remember that if a section is in positive bending, the top section, the top extreme fibers will experience compression forces. And the bottom part of the section will experience tension stresses. So, do you think na isasali pa natin tong stress sa top? Iko-compare pa ba natin siya sa rupture? Of course, hindi na. Dahil, ulitin ko, ito ay in compression. Itong nasa bottom, ito yung nasa tension. So, we will only compare it to the tension stresses. So, itong bottom na ito. Okay? So, therefore, mapapansin nyo, equal sila sa computation natin. So, therefore, yung section natin will now start to crack. It is assumed to start to crack now. Okay? So, next meeting na natin i-discuss ito. Yung determine na kung susundin natin yung sinasabi niya lang, what is if we have a simple span, so ano daw yung parang pinakamabigat niyang distributed load na mabubuhat? Okay? Ano daw tong pinakamabigat na distributed load na ito? So yun yung parang tanong niya. So, okay. Pero distributed load, so yung kilonewton per meter ang natin. Okay. So that would be yun lang muna sa oras na ito. Alam ko may klase kayo ulit. So, tap ko na ito. Screenshot ko lang. Alang, may late. Nalagay. Mamaya may klase pa tayo ng
7:30, sir.
7:30 na. Okay. So, kita-kita ulit tayo.
Sige, sir.
Thank you po, sir. Thank you po.
Thank you po.
Bye, sir.
Thank you, sir.
And
Thank you, sir.